When we see a polynomial and an exponential function within the same integrand, we really should be thinking about integration by parts. First, we always want to check u sub. If we were to take the derivative of negative x, let's say we let u equal negative x, and du is just -1, so we really, no matter how we slice it, we're not going to be able to be successful with a u sub on this one. And we certainly don't have a formula for this, so we're going to try integration by parts. And remember Lipit. Lipit says that we're going to take this polynomial function here and let that be equal to u, the p before the e. So 4x plus 5 is our polynomial function. And then our dv, of course, is the rest. E to the negative x dx. And then our antiderivative of e to the negative x would be negative e to the negative x. And then our derivative of 4x plus 5 would just be 4 dx. So therefore, let me get a different color here. The integral can be written as uv, so we have u times v. So that's a negative 4x plus 5 e to the negative x. I just brought that minus sign right there. I brought it out to the front. And that's minus the integral of v du. So we got to connect these guys now. Minus the integral. And there's a minus sign again right there. So let's make that a minus for a plus. And we have 4e to the negative x dx. All of that is evaluated from 0 to 2. So I like to write it like that because I don't want to forget that I want to make sure we're integrating or evaluating this part of it as well from 0 to 2. And we can just go ahead and evaluate that antiderivative. And when we do that, we get a different color. We get negative 4x plus 5 e to the negative x, and then the antiderivative of 4e to the negative x is negative 4e to the negative x. And we don't need a plus c because this is a definite integral. So we're going to evaluate this whole thing. We're going to evaluate this entire antiderivative from 0 to 2. And so let's go ahead and do that. We're going to replace x. Everywhere we see an x, we're going to put a 2. 4 times 2 plus 5 times e to the negative 2 minus 4 times e to the negative 2 minus all the rest of it, negative. Now I'm going to replace x with 0 now. This antiderivative evaluated at the lower limit of integration, so negative minus negative 4 times 0 plus 5. And then we have e to the negative 0, running out of room here, minus 4 times e to the negative 0. And all of that is what we subtract from. Now, it's a big mess right now, so let's see if we can simplify this. So 4 times 2 is 8. 8 plus 5 is 13. So we have negative 13e to the negative 2 minus 4e to the negative 2. And then this minus, let me do that again here. Identify this here. We have a minus here. We're going to distribute to this minus as well as that minus. So everything becomes a plus. So then we don't have to worry about minus signs anymore. And we get, let's see here, where are we? So there, and we have plus 4 times 0 plus 5. So that's 4 times 0 is 0. Times 5 e to the negative 0 is e to the 0, which is 1. And then we have plus 4 times e to the negative 0 again. E to the 0 is 1, so plus 4. So if we combine like terms, we're going to get negative 13 e to the negative 2 minus 4 e to the negative 2. And then these guys are also like terms. And so then we have negative 17 e to the negative 2 plus 9. That's it.